Hi there guys, and welcome to Kinord. This is my second layout. This is like a small exhibition layout. It's only two baseboards, and this is a smaller project which I've been working on. It's still under construction, but you can get the basic idea. It's got two double tracks, terminating station at the back, and then a single line fuel depot at the front. So this is the front scenic layout part, and the other baseboard is a smaller fiddle yard, which would be covered up for exhibitions. As I say, it's still under construction, so all the walls aren't there. So I'm going to be giving you a demonstration of the layout and some of the things I've been working on. So some of the scenery is down. The majority of the station is done. There's still quite a few things, bits of smaller parts to do. We've got the bridge at the back there still being worked on, and quite a lot of the front scenery. You can still see the paper mache in the way there. So that's the scenic side, and on the other side is the fiddle yard and sort of the control side of it. So we've got 67030 here doing the demonstration today. This is DCC, loco, no sound. This is the old model actually, and this is the control panel here. If you've been seeing the topic on the Model Railway Layouts forum, I've been working on this control panel over the last week or two. I started putting it together, and it's all-in-one system, so it's going to contain, it's still under construction, but it will contain all the controls for the entire layout. So from left to right, we have the TV Arduino. This is the larger model, because the TV screen uses quite a lot of memory to store all the pixels in it and run the memory buffer. I've upgraded the controller here, where this model does have a bit more memory. So that's connected directly to a board underneath with two resistors on it, which provides the TV signal, and that goes to the 7-inch LCD display on the fiddle yard. This runs off a 12-volt power supply and draws very little current. So I've got my lab power supply hooked up here at the moment on 12 volts, which powers the whole thing. So that's that. Next is the these two boards, the Arduino and the small PCB here, are the DCC controller. So what happens is the Arduino here forms all the DCC packets, which send through these two signal wires, which is connected to the board on the input side. This board then takes a 12-volt power supply, ground, and 5 volts, and then boosts the signal from 5 volts to the 12-volt AC DCC signal, which goes out and then is connected up to the track, like there, and that just plugs into the layout, and that's the DCC. On the controller side, there are two toggle switches there, which are going to be for functions and not completed yet, and the main controller, which is the 2-axis joystick, so it goes back, forward, left, right. So that's that, and it's connected up to the Arduino as well. Then everything is powered off 12 volts. So that's how that works. I'm going to give you a demonstration now. Now, initially I wanted to combine the two Arduinos into a single one, but that unfortunately wasn't possible. It took quite a lot of work to find out why as well. But because the timings of both DCC and TV are so accurate that they can't sort of overlap each other, so like the timings for the DCC packets have to be so precise so that the the DCC chip on the train can understand what the packet says. They need to be sent at exactly the right time. And same with the TV signal. if the TV is not sent out at the right time, then the picture's screwed up. So I had to separate the two of them, and then I connected them via a serial link. So it's just two small wires which interlinks two boards and sends the information from one to the other, and they come up on that side of the board, and this one on the other side. So this is the signal transferring the data between the two. So the demonstration, we've got the 67 there. It's on channel 3 DCC channel. My EZ command unit is usually plugged into here. So this is the DCC plug for a controller, but in this demonstration it's all running off my system, so it's not required. The joystick forward back produces a signal which is then translated by the Arduino and produces which voltage and which direction to send to the locomotive through the booster unit. So on the display, once the signal has been received from the controller, it goes through, also sends that same signal to the other Arduino, which displays it on the TV screen. So we've got forward and reverse here. This screen is still slightly buggy. As you can see, it's flashing there with a -1 value, which is obviously incorrect. So we've got forward power at 0 and reverse power at 0. So if we push the joystick forward, indicating to go forward on the locomotive, train moves, and we can see how much power is being applied on the screen there. Let me just get a better shot of that for you. So we've got forward power currently at 0, and just tipping the controller forward, 6, 7, and back down to 0. Then when we pull the joystick back, it tells the Arduino that the train wants to go in reverse, and it starts reversing. And on the LCD display, the signal is sent and then translated, and we've got reverse power. The value changes between 0 being the minimum speed and 10 being the maximum speed. Also on the loco, all functions appear to work. We've got function 1, which is the extra headlight which I added there. It's just an LED, and when we tip the controller forward to change the direction, you can see that the front lights also switch direction between back and forward, depending on which direction the loco is going in. We can also turn the loco off, the lights on and off, which I plan to do manually through the toggle switches. So that's a basic overview. I mean, this system is relatively cheap as well. I've gone for the expensive option with the dual Arduinos, which are running in parallel together, sending the signals between each other, which is a more expensive way of doing this. I have maybe a bit more of a budget, but if you want to do it on the cheap, the DCC booster board, the L298N I believe is fairly cheap. It's just about £5, and that takes the signal from the Arduino. You can get a cheap Arduino on eBay, for example, for about £8 or £9 if you buy, I think, a few, so maybe just a little bit more for a single unit. The Arduino Nano is a good one to choose. I've seen people use this system similarly with the Arduino Nano, and that it's got less memory, which is bad for the TV signal. You can get, your resolution won't be as good, but it'd be fine for DCC signals, and that's about £8 or £9. The entire DCC controller might cost £13 to £15. which is cheaper than well, buying one, but it is a bit more hard to work with, I suppose. But I mean, the expansion on this system is phenomenal. I plan to also integrate my F1P train optical detectors into this system and place a couple of those in the track, perhaps at the end of the station, for example, the platforms. So if the detector is triggered, for example, it also may display on the LCD screen, but it could activate an emergency shutdown in the SD system, where all the trains could slow down or turn off before they reach the end of the platform. So that's one example. I also plan to get some lighting on the layout and also integrate that into the controller. So there's quite a lot of options, which I'll be able to do on just this one control panel. So that's about it. Another feature that I've done is with the 0 to 10 speed. I mean, it is possible to go higher than 10, but because it's a small layout, I've actually speed governed it, so you can't actually push the controller higher than 10. So the maximum is 10, and it cuts off there, so you can't, well, it's less chance for an error and getting the speed stuck at full power and then crashing. So that's another possible option on the smaller layout, perhaps not as good for a larger layout where you want a bit of speed. So that's about it. So thanks very much for watching, and perhaps see a bit more, another demonstration another time. Thanks for watching.